Hey, welcome back. Day 2 of Basic Math 7. Here we go. We're going to review what we talked about yesterday, and we're going to do the even problems of what we did the other day. So another 13 problems today, 2 to 36 on page 259. Okay, the written exercises. That's what we got to do today. Let's go over our rules that we've been going through as far as how to solve these problems and what we need to think about as we're doing the problem. That way we get the procedure down. So when we look at this one, remember, we're going to first look to see if we have to combine any terms. Most of the problems, or none of the problems today, we have to do that step. So that one means we go down to this one. The next step would be isolate the variable. That means add or subtract numbers away from the letter. Don't have to do that one today either. That's why I have this one asterisked, okay? Because this is where we're at. We're focusing on this. And we're using fractions and we're using decimals, and sometimes we're using decimals and fractions as we talked about or looked at on the lesson yesterday. So let's go back to this. This will probably be a little bit shorter one. I'm going to go through a couple of sample problems. I'll do a couple of the problems that we have to do today with you a little bit, some of the harder ones, so that you kind of get the concept or the flow, and then I'm going to let you loose. If you have any questions, make sure you communicate to me. Atlee, good job of communicating. I appreciate that very much. I haven't heard much from the rest of you, so make sure you're communicating. Sam, way to get your assignment in. That's a good job also. So let's take a look at what we got here. So on this problem, we have, of course, a fraction. And remember, when we talked about the fraction when it's right next to the letter, that means what operation? Multiplying, right? So the reason or how we get this fraction away from the decimal or from the letter, the variable, and create just one variable is do the reciprocal. That's right, recip. I put recip down there. So the reciprocal of 1/9 is 9/1. If I multiply to this side, I got to do the same multiply to that side. In this situation, I have no canceling out that I have to do, so I just multiply straight across. These cancel, and P will equal whatever 33 times 9 is. I'll do that down here. I hope you can see that on the screen. I hope I didn't go too far to the right there. Get my head out of the way too. 3 times 9 was 27. Carry the 2. 3 times 9 is 27 plus 2 is 29. So in this problem, P equals 297. Let's try one more of those types of problems. Think about it. 2, 7, H equals 8. Fraction. We multiply by the reciprocal on both sides of the equal sign. There we go. 7 and 7 cancel out. 2 and 2 cancel out. That leaves me with only one H, and there it is. And then over here, put 8/1 and look to cancel before we multiply, because we can. A number will divide to both 2 and 8, and that number is, that's right, 2. 2 goes into 2 once, 2 goes into 8 4 times. Now I multiply across. 4 times 7, 28. 1 times 1, 1. 28/1 is just 28. That's right. There's our answer for that one. Remember, when you submit this, you want to do it on a Google Doc, and you put the number down and make sure you make the letter equal your answer, okay? All right, and once again, like I said before, when you have a fractional answer, just put that slash mark for your fraction. So if it was 28/29, it would look like that. It's not. The answer is 28 on this one. Okay, let's delve into those decimal ones, which I think are a little bit more difficult to handle, especially because we have to divide with those decimals. We have to remember the rules about dividing with decimals. Okay, so let's look at this list problem. 1.78u equals, or excuse, not 7/8, 1.8u equals 5.76. Okay, thinking cap on, number next to a letter means what operation? We have to do the opposite of that then. So if this is multiply, we put a divide line. That's what that line on a fraction is, a divide line. And divide by that same number so those two can cancel out and give me just a single letter. 1u, one variable. Same thing. Over here, we're going to divide by 1.8, because if I divide here, I have to do the same on the other side. Always remember, we start by looking at the side with the letter on it and then moving over. Sometimes our letter can end up on this side, and that's okay. Just start on that side, trying to get rid of the numbers in front of it or underneath it. All right? So on this one, we do a division problem. And so the top number goes in the box, 5.76. The bottom number goes outside. And remember, when you have a decimal in your divider, you have to get rid of that by moving it over to the right one place. And that means our decimal point moves over to the right inside the box. If there's not a number there, scoot it over and put a 0 there. Okay? So now I'm going to say, how many times does 18 go into 57? Well, 18 is close to 20. So if I think, probably close to 3, because 20 times 3 would be 60. We'll see. I'm probably pretty close. 8 times 3, 24. Here, we'll do down here. 24, carry the 2. 3 times 1, 3 plus 2, 5. Ooh, perfect. 54 is less than 57. That's good. Subtract. 7 minus 4, 3. Bring down a number, 6. Okay, well, yesterday I talked about it being half. This one's double, so that was easy. A double of 18 is 2. I can go through the motions and do 2 times 18 to prove it to you that it's 36. 2 times 8 is 16, carry the 1. 2 times 1 is 2, plus 1 is 36. It came out even. Once again, all our answers will be terminating. That means they end. They don't have any repeating answers or repeating decimals. So if you come up with a problem like that, you need to rethink it. Go back and look at it. Okay? The answer to this problem was 3.2. Let's try one more of these. Again, anytime you feel free to go back and take a look at this, look through these steps again, make sure you're doing the process right. That's always good. Okay, so, where's my, okay, here we go. 3.4a equals 3.74. Same thing, right? So we take and put a divide line and divide by 3.4 on both sides. These cancel out and give me 1a. Over here, 3.74 in the box. 3.4 outside the box. Next step. Do we have a decimal in our divider on the outside? Yes, we do, so we have to move it. One place. Now start to divide. This can look if you can think in your brain, this is a pretty simple problem. 34 goes into 37 once. We subtract, get 3, bring the 4 down, bring my decimal up in my answer. Once I get past that decimal, I got to bring it up in the quotient up here, the answer box up on top. Okay, 34 goes into 34 once, and we terminated it. It's the end. It ended. Okay, answer is 1.1. Pretty doggone simple. Now, let's take a look at a couple of problems on today's lesson. All right, I will do one decimal problem, and I will do one fractional problem, okay? So, looking on, we have all the way to 36 today, 2 to 36. And so let's tackle that big one right away. Let's tackle 36. Okay, look what it says there. It has n over, oh, that's quite the decimal, 0.09 equals, this is number 36, 2.79. Now, we didn't practice this. This is part of the reason why I wanted to do this problem today. This one's different, right? We already have a divide line. That means that we're dividing here. The opposite is multiply. So we're going to multiply by the number that's dividing into the variable. That is multiplying by 0.09. 0.09. Now, we have to remember our multiplication rules with decimals. Step 1, multiply the problem like there were no decimals. So let's do that. 9 times 9, 81. 9 times 7, 63 plus 8, 71. 9 times 2, 18 plus the 7 we put over there, we carried over, 25. 18 plus 7 is 25. Now, after we've done that, go back up into the multiplication area and count how many numbers that are behind decimals. I got 1, 2 here, 3, 4 there. So we got to move the decimal place 4 places. We start at the end of our problem and move 4 places over. And there it is. It goes right in front. If there are not enough numbers, add zeros in front. Okay? This one, fortunately, had enough numbers. The decimal goes right in front. So my answer is n equals 0.2511. Checks out with my book answer too. Good deal. There's 36. You can pause the tape or a video or whatever so you can jot that down if you need to. I'm going to move on. One more. Let's look at number 22. Okay? 6 over 5 times n equals 20. Okay, we have a fraction, which means we're going to do the reciprocal. So we multiply by the reciprocal on both sides. 5 over 6 here times 5 over 6 here. These cancel. Now, make sure you put 20 over 1 and look to cancel before you multiply. Okay? 6 and 20. Well, 6 doesn't go evenly into 20, but there's a number that divides into both 6 and 20. That's 2. So 2 goes into 6 3 times, divides into 20 10 times. 3 won't divide evenly into 5 or 10. So we're kind of finished there. Go ahead and multiply out. 10 times 5, 50 over 3. We have an improper fraction. So in order to get the answer, this one's going to be a mixed number. So 50 divided by 3. 3 goes into 5 once. Subtract. We get a 2. Bring down our 0. 3 goes into 20. 6 times. 3 times 6 is 18. Subtract 2. We had a remainder. Now remember, when you have a remainder and we brought down all of our numbers, we don't keep going on. We aren't changing it to a decimal. We're going to keep it as a fraction. This remainder becomes the top number or the numerator on the fraction, and what we divided by becomes our denominator. Okay? Got to remember all that stuff we went through. So then that's what n equals. 16 and 2/3. It's a mixed number. Right? Okay. So there it is. That's how you do that one. Actually, number 24, going to be the same way. That one will be a mixed number also. So you can put that as a note in your book. This one was number 22. So if you need to go back through and pause and say, okay, 22 was this, here it is. All right, Tomorrow, we're going to meet together on Zoom. I will send a link in the morning for you to click on to get on the Zoom meeting, and we can talk about tomorrow's lesson then. And then Thursday, I'll do a little bit of a review lesson with it, and then we'll move on from there, okay? Hey, good to be talking to you again. I hope that you're getting all the links together. If you're not, just remember, I'll send out a link kind of a day at a time until I get a little bit ahead of schedule here. And then I'll have maybe a couple of links that you can do, and it'll say what day you use that link for. Okay? All right. Have a good day. See you later.